Assalamualaikum warahmatullahi wabarakatuh. For the question 1 about the AC network analysis, an unknown circuit figure 1 with an input voltage supply give an output voltage shown in figure 2. Propose a circuit with drawing that yield the result in figure 2. Please use resistor and capacitor. Okay, so for the question 1, we need to draw this, which is the high pass filter. This is the formula. We use V voltage divider rule, and for the period we got it from the graph. Start from here until this for the 1 period, which is 1 to 5 millisecond, and we can get the frequency, which is 8 Hz. Using the 8 Hz, we can calculate the omega, and then we assume the C equals to 0.1 microfarad, V input 5 volt, V output 3 volt. So substitute this formula, and lastly we got the resistor, which is 149.2 kilo ohm. And we use this formula to calculate the angle, and then we get the angle for V input, which is 109.47 degree. Okay, for the simulation for question 1 using the LTSPICE, we use the voltage, use the voltage and the capacitor, control R for the rotate, and the resistor. We need to make the circuit for high pass filter. Connect all these components, and don't forget the ground. Right click at the voltage and click advance. At the sign, DC offset is 0, amplitude is 5 because the voltage input is 5. The frequency we get it 8, delay is 0, 0, and our phi is 109.47, and the AC amplitude is 1. For our capacitor, we assume before, which is 0.1 micro, and we got from the calculation, which is 149.2K for the resistor. And then we click the simulate, edit simulation, transient. Our stop time is 250 millisecond. Click here, and then we can run, but before that click the label net for V output, put it here, and for the V input, okay, then we run, click here and here. So we can see the graph is exactly the same as the given question, but the voltage is start from the 0, but in here is 3, same, still same. So this is for the question 1 for the simulation. Okay, for the question 2 about frequency response, an unknown passive filter give an frequency response of gain and phase shift shown in figure 3. The value of FL, FC and F hash is 1 kHz, 5 kHz and 10 kHz respectively. Propose a circuit with drawing that yield the result in figure 3. Please use resistor and inductor. Okay, we draw this circuit, which is this is a high pass filter and this is a low pass filter. We assume the value of inductor is 0.2 Henry, and this is the formula for cutoff frequency. We got 1.256 kilo ohm for the low pass filter and 12.6 kilo ohm for the high pass filter. And then we should use this formula to calculate the inductor value. We substitute for the low pass filter the value of resistor, substitute in this formula, and we got the inductor value, which is 0.2 Henry. And for the high pass filter, it's also the same method. We just substitute in this formula, and we also get the value, which is 0.2 Henry. Okay, for the question 2, for the simulation, we need the voltage, the resistor, here, and the inductor, this is we need to connect it in parallel. And for this one, we need to connect it in series. Then we need the ground. V output. Okay, right click at the voltage source, advance, sign. The DC offset is 0. Our amplitude is, I assume, is 1 and frequency is 1 kilo. AC amplitude is 1. Click OK. And our inductor, before that we got 0.2. For both of it. And for the resistor, we got 12566.37 ohm, and for this resistor we got 1256.64, and then we click the simulate, edit simulation. We need to click at the SC analysis. Type of sweep, we use decade. Number of point per decade, we use 100. Start of frequency at 1 and stop it at 200 kilo. After that, we run it. Click at the V output. So we get actually not the 100% same at the question given, but we can see it is a band stop filter. This is the low pass filter and this is the high pass filter. For the frequency, cutoff frequency, we can see it may be at negative 3 decibel. We got 679 Hertz, and for the F hash, we can get it maybe around 14.6 kilohertz. For the FC, we can get it for 3.18 kilohertz. I think that's all from me for this video. Thank you very much for watching this video.